Hey guys, this is the solution for number 3, what I got. So what we're given is using the Laplace transform for L f of t for f of t on the defined interval of t greater than 0. So the first one we have 4e to the power of negative 5t minus 1 half t squared plus 3t minus 9. So I noticed that this has a linearity property of Laplace transform. So what I did was I took out the constants in front. So I got 4L and then brackets e to the power of negative 5t minus 1 half L brackets t squared plus 3L brackets t and then minus L of 9. After that, I solve for each part individually. So the first one, we have L of e to the negative 5t, which is 1 over s plus 5. And then using the website the professor gave us for Laplace transform, a table of them, e to the power at is equal to 1 over s minus a. In this part, we have negative 5, so it's going to be s minus 5, so that makes it positive. That's why it's positive. The next one is t squared, and the answer I got for that is 2 over s cubed. In this case, we have t to the power of n where it equals 1, 2, 3, etc. And then the form of n exclamation mark over s n plus 1. Rn is equal to 2, t squared, n equals 2. So we have 2 times 1 over s of n plus 1, which is 2 plus 1. We get 2 over s cubed. Next part is the same thing, except in this case we have t. In this case, our n is 1, so it's going to be pretty simple. And it's going to be 1 over s squared. And the last one is just a number, L of 9, which is 1 over s, and in this case, it's going to be 9 over s. So for the next part here, after finding each of those, we plug it back into the function with the constants in front. So we have 4, 1 over s plus 5 minus 1 half, 2 over s cubed, plus 3, 1 over s squared, minus 9 over s. I simplified it by multiplying each thing to each other. We got 4 over s plus 5 minus 1 over s cubed, plus 3 s squared, minus 9 over s. That's your final answer right there for 3a. Just combining everything all together back into the equation. 3b, we're going to have e to the power of negative 2t cosine square root 3t. And only 3, it's square root 3, not square root 3t. Minus t squared e to the power of negative 3t. Now, based on the tables here, I found negative e at, well, not really negative, but e to the power at cosine bt, and that's the answer form of s minus a on top. The bottom is going to be s minus a squared plus b squared. For next one, it's going to be t to the power of n e to the at, which is going to have the form of n exclamation point divided by s minus a to the power of n plus 1. Go over next part here, side by side. So first one here, we're going to have s plus 2. Remember, over here, it's going to be s minus a, but since our a is negative, it's be s plus 2. And then we have our a again here, s plus 2, to the power of n, and our n is 2, plus 3. So this 3 right here, that's going to be b squared. But since we have square root of 3, it's going to cancel out and just give you just regular 3. Next part is very simple as well. We have L t squared e to the power of negative 3t, and we get 2 over s plus 3 cubed. Now just memorize this formula right here, and then we have our n, which is on top, which is 2, so it's 2 times 1, and then s minus a, but since it's a negative 3, so it's become positive. So it's going to be s plus 3 to the power of 3, because it's going to be n plus 1, so it's going to be 3. Now, final thing is just putting it all together. Remember before it's given that there's a negative here, so this would be minus each other. So we're just putting 1 and 2 together as your final answer.